All right, guys, back to reviewing for the final exam. We left off on number 41. All right, and it says solve each triangle. If no triangle exists, state no triangle. All right, so part A gives us alpha is equal to 10 degrees, gamma is equal to 40 degrees, and side C is equal to 2. Now, again, if you don't like alpha, beta, gamma, all right, obviously these are angles since they have degrees, right? So we can just call this A and this C, all right? Of course, beta looks a lot like a B, so that would be pretty easy. Okay, now what I recommend you do here, right, if we have A, B, C, A, B, C, okay, well, we're given A, we're given C, and we're given C. All right, so this is side, angle, angle. All right, or angle, angle, side. All right, which means we can just go ahead and use law of sines. So we can say sine of 10 degrees over side A is equal to sine of 40 degrees over side C, which is 2. So now we cross multiply and solve for A, and we will get A is equal to 2 times sine of 10 degrees divided by the sine of 40 degrees. All right, so sine A is going to be equal to, if we plug that into our calculator, do make sure that you're in degree mode in this case. Alright. And we will get A is equal to 0.540. And that's a side length, remember. Okay. All right, we can also very easily find our missing angle. Right? We know that angle B, these all have to add up to 180. If these two add up to 50, then this has to be 130 degrees. All right, and we can go again. We can say sine of 130 over B is equal to sine of 40 over 2. Remember, we want to use the pieces that have not been rounded, like the exact pieces that we were given whenever possible. So doing here, B is going to equal 2 times the sine of 130 divided by the sine of 40. And when we do that, B will equal 2.384. And we're done. All right, so that was 41A. Now we can look at 41B. All right, and here we have A is equal to 10. B is equal to 7. And C is equal to 8. So here it's obvious that we have all three sides. So we're going to want to use a law of cosines, which again will be on your formula sheet given to you. There's two different forms. Since we're looking for an angle, we're going to want to use the form that says cosine of A is equal to B squared plus C squared minus a squared all over 2bc. So eventually we're going to take the inverse cosine of both sides. All right, and then I just plug in my stuff. So 7 squared plus 8 squared minus 10 squared over 2 times 7 times 8. All right, and if we go ahead and plug that into our calculator, we will get 83.3 degrees. All right, now we need to find angles angles B and angle C. Remember, now we know that A is the largest angle, so we can find whichever one we want. Remember, you do kind of have to be careful here, all right, because of the way inverse sine works. That it doesn't like angles over 90 degrees, basically. In this case, we don't have to worry about it, but just to be safe, always find the smaller angle first. So we would find B first here. So we would say sine of 83.3 degrees over 10 is equal to sine of angle B over side B, which is 7. We multiply both sides by 7 here. And then to get angle B, we will take the inverse sine of that whole thing here. So we will go ahead and plug that into our calculator. And we get 44.0. Get our third and final angle, angle C. All right, we simply add these together, subtract from 180. All right, so this is going to be 127.3. So that should be 52.7. If I did that correctly in my head. And we're done. All right, letter C. We have A is equal to 3. C is equal to 1. And gamma, which is the same as angle C, is equal to 20 degrees. All right, so again, we can check what case we have here. All right, so we have A, C, and C. So we have angle side side or side side angle. All right, so that's going to be our ambiguous case. All right, so remember we want the two sides that match up to be A, and the extra side needs to be B. So the first thing we need to do is find H. H is equal to B times the sine of angle A. So when we plug that into our calculator, we get 1.026. Right, and then this is where we compare, and all of that ambiguous stuff will be on the formula sheet that I give you. So is A less than H? Yes, right, because this is my new A. So A is less than H, right? So we have no triangles. Yay! We don't have to do any more work. All right, 42. So let's find the area of each triangle. again, there's a couple of different area formulas on your formula sheet. All right, A says that A is equal to 4.1, B is equal to 3.2, 3.2, and C is equal to 5.9. All right, so we have all three sides here, so we need to use what's called Heron's formula, which A is equal to the square root of S times S minus A times S minus B times S minus C, where S is equal to A plus B plus C all divided by 2. All right, so first we're going to find S, and that is 4.1 plus 3.2 plus 5.9 all over 2. All right, so that's 13.2 divided by 2, which is 6.6. So our area is going to be equal to S, which is 6.6, times S minus A, which is 2.5, times S minus B, which is 3.4, times S minus C, which is 0.7. So we plug that into our calculator. And we should get 6.267. Done. All right, 42b. All right, says that b is equal to 4, c is equal to 10, and angle A, which they give as alpha, is equal to 70 degrees. All right, now whenever we're given two sides and an angle, and all of the letters are different, that's where we do A is equal to 1/2 times each side times the sine of the angle. So you plug that into your calculator, and you get 18.794. Done. All right, 43 says to use back substitution to solve the system, and it is 2x minus y plus 5z is equal to 16. We have y plus 2z is equal to 2, and we have z is equal to 3. Okay, so we know z is equal to 3, so now we go backwards up to this equation and plug in z. So y plus 2 times z, which we know is 3, is equal to 2. This is 6, subtract 6 from both sides. Y is equal to negative 4. Now we go back up to the top and plug y and z in, and we get 2x minus y, which is negative 4, plus 5 times z, which is 3, is equal to 16. All right, so here we have positive 4 and positive 15, right? So that's positive 19. So we subtract 19 from both sides, we get negative 3, divide by 2, x is equal to negative 3/2. So now our final solution would be negative 3/2, negative 4, 3. Done. All right. 44. Use matrices and Gaussian elimination to solve the following system of equations. All right, so I'm just going to go ahead and jump straight to putting this in a matrix instead of writing down the equations. So we're going to have 1, 2, -1, 3. All right, we're going to have 3, 7, -5, 14, and -2, -1, -3, 8. Okay, so we're doing just Gaussian elimination here, so we want to get this in just regular row echelon form. Doesn't have to be reduced. So in order to do that, I want my first row here to start with a 1. It does. So I will just keep row 1 the same. And I want this to be a 0. So I'm going to say -3r1 plus r2. So -3 plus 3 is 0. -6 plus 7 is 1. +3 plus -5 is -2. And -9 plus 14 is 5. And I want this to be a 0. So I'm going to say 2r1 plus r3. So when I do that, 2 plus 2 is 0. 4 plus -1 is 3. -2 plus -3 is -5. And 6 plus 8 is 14. So one time through, I got my first column how I want it. All right. Yeah, with just Gaussian elimination, I don't have to worry about these being zeros. Okay. As soon as I have 1 and a bunch of stuff, I'm good. As soon as I have 0, a 1, and some stuff, I'm good. So my row 1 and my row 2 are fine. So 1, 2, -1, 3, and 0, 1, -2, 5. All right, and I want this to be a 0. All right, so I can actually say -3 times row 2 plus row 3. So here's still 0. Now -3 plus 3 is 0. +6 plus -5 is 1. And -15 plus 14 is -1. All right, now this is in row echelon form. And if we think of this in terms of our system, right, this tells me that z equals -1. Then I can do my backward substitution like I just did and come up here. And I know that this means y minus 2 times z, which is -1, is equal to 5. So y plus 2, so I subtract 2, y is equal to 3. Now I plug both of these in up here. I'm going to get x plus 2 times y minus z is equal to 3. So this is 6 plus 1 is 7. So I subtract 7 from both sides. X is equal to -4. So my final solution, -4, 3, -1. And we're done. All right, number 45. All right, it says find the product of the following matrices. So A is equal to 4, -2, 3, 2, and B is equal to -1, 4, 5, 2, -2, 1. All right, so this is a 2 by 2. This is a 2 by 3. Since these numbers match up, I am allowed to multiply them, and my answer is going to be a 2 by 3. So A times B, which I will call C, is going to equal a 2 by 3. All right. Now, to do C11, right, I take this row times this column, right? First row, first column. 4 times -1 is -4, plus -2 times 2 is also -4, so this equals -8. All right, C12. All right, well now I'm still on my first row, second column. So now I have 4 times 4 is 16, plus -2 times -2 is 4, so this will be 20. Right now, I'm looking for C13, so that's going to be first row, third column, and I'm going to get 20 plus -2, which is 18. All right, C21. So now I'm in second row, first column, and that will be -3 plus 4, which is just 1. C22. Now I'm in second row, second column, so I get 3 times 4 is 12, plus 2 times -2 is -4, so this is 8. And finally, C23, second row still, third column now. 3 times 5 is 15, and 2 times 1 is 2. Add those together to get 17. All right, and we are done. 46. All right, find the inverse of the following matrices. All right, so we have A is equal to 2, 1, 0, 3, 0, 1, 4, 2, -1. All right, remember, anything bigger than a 2 by 2, we're just going to use our calculator. So we go here to the matrix menu. I'm going to edit. All right, this is a 3 by 3, so I'm good there. I'm going to want 2, 1, 0, 3, 0, 1, 4, 2, -1. All right, now all I have to do is quit out of here, go back into my matrix menu, hit enter on A, hit this little to the -1st button, and this will give me my inverse matrix. If it's messy fractions like this, that's fine. Just hit math, enter, enter, and it will change it to fractions for you. Okay, so A inverse is equal to -2/3, 1/3, 1/3, 7/3, and I'm going to want more room here. That's not what I want. Where's my eraser? There we go. Right, so 7/3, -2/3, -2/3, 2, 0, -1. Right, and that's it. That's all we have to do. All right, so 46b, all right, similar. All right, so b we're going to have 0, negative 2, 4, negative 5, 2, negative 3, 7, 3, 6. So I go back to the matrix menu. I'm going to edit matrix B. It is a 3 by 3. We have 0, negative 2, 4, negative 5, 2, negative 3, 7, 3, 6. We can quit out again. We can go back to our matrix menu, go down to B, do our inverse here. Again, it's a little messy. Let's math enter, enter to get it into fractions. Still messy, but that's okay. All right, so we're going to have negative 21 over 134, negative 12 over 67. I don't really feel I need to write all of these down at this point, right? They're all right here. All right, so you can easily see all of those. All right, now we'll look at number 47. And it says, use an inverse equation to solve the system of linear equations. All right, so we've got negative x plus 4y minus 2z is equal to 12, and 2x minus 9y plus 5z is equal to negative 25. Negative x plus 5y minus 4z is equal to 10. All right, now when it says use an inverse equation, what they mean is that we want to use x is equal to a inverse times b, right, where a is the coefficient matrix, so negative 1, 4, negative 2, 2, negative 9, 5, negative 1, 5, negative 4, and b is the constant matrix, which is 12, negative 25, 10. All right, so all we have to do is plug these into our calculator. All right, so we go back to our matrix menu. We edit. A is still a 3 by 3. And I've got negative 1, 4, negative 2, 2, negative 9, 5, negative 1, 5, negative 4. All right, then we go back to our matrix menu. We're editing matrix B. This is a 3 by 1 matrix, and it is 12, negative 25, and 10. All right, so now I can quit out. All right, I can go to my matrix menu, hit enter on A, hit my inverse, go back to my matrix menu, go down to B, hit enter there, hit enter, boom. So matrix X is equal to negative 2, 4, 3, which means this is my X, this is my Y, this is my Z. Negative 2, 4, 3. Done. Okay, so the rest of the review, numbers 48 through 58, are vectors and complex numbers in trigonometric form. So just for time purposes and not having any one video super long, I'll go ahead and stop here and put up a new video with the final 11 questions.